Hey everyone, welcome to another episode of the Common Lisp Study Group. I'm your host, Ram Badam with Atlanta Functional Programming. Today we're going to be continuing our discussion on Roswell, the implementation package manager, and actually multi It's I guess I'm now convinced after reading the documentation and stuff like that that it's a multi-purpose tools for dealing with managing multiple installations of different Lisps to actually installing scripts for you. It'll allow you to actually also actually set up and be used as a testing environment. It can be used for um, even distribution of your executables once you actually have them, as I attempted to show you last time, and but I made a small mistake, which we're going to be covering today. And then finally, we're gonna just, there's just a lot of stuff here. So it's actually a pretty great environment. I've been using it for quite some time, just for managing Lisp implementations and scripting environments. So in that respect, I was using it more like just a tool to set up and deal with uh, writing out different types of scripts and projects and build things like that just in a cross Lisp manner. This way, you don't necessarily need to know which Lisp you are actually building against, and you can actually just simply run Roswell in your Roswell scripts uh, on any Lisp, provided that you've downloaded the appropriate Lisp on your machine. Last time we attempted to create and install a utility that we wrote on computing the factorial, and I was trying to kind of show you a couple things related to actually doing that, and I tried to show it to you through the ROS install command. Now, we were having a little bit trouble there. As it turns out, I went back to the documentation and looked into this just once again, and I misread what they said. It's not just that you need to have a Roswell subdirectory with your scripts being available in there. If you are building an application or a command line tool, you can actually set it up, and this is regardless of whether you're running Windows, Mac, or Linux. You can actually set it up with the Roswell scripts being in the Roswell subdirectory so that it can download from GitHub into your local projects directory, compile your code with your Roswell script using ROS build, and then put that executable into your Roswell installations bin directory. All right. If you're using Linux, it's going to be, $home slash dot Roswell slash bin. On Windows, your mileage may vary. Unfortunately, I don't have a Windows machine to show you guys this, but we will go through an example here just to illustrate some of this stuff. As usual, for those who are viewing our stream online, and you are looking forward to asking questions. We are more than happy to answer them while we go through this example. I do apologize for those of you who are expecting us to start at 7:30. Unfortunately, I was having a couple of technical difficulties, and then we ended up having a few other questions prior to the start of the stream. So, but we'll get started, and hopefully we'll go through the rest of the discussions today, as well as starting up our GitHub Actions discussion too. But if you have any other questions, feel free. This is kind of an informal discussion. Atlanta Functional Programming study groups are usually just us hacking away and me showing some stuff that I found interesting, as well as if folks are watching, discussing anything you guys want to talk about. So feel free to ask any questions that you have, and I'll answer them whenever I get to them. All right, whenever I see them on the stream. So let's start back to what we were looking at last week, which is the ROS install that we created. So we have this factorial program that we wrote here. And what this was actually trying to do here is create a simple tool that just, kinds of shows if they didn't provide a number to the console, will give some usage. Otherwise, we'll call our factorial function. Now I'm going to create this and, go back to this and update this to use more of a format string just merely because I found out that, when we're compiling this, that this doesn't actually create a proper new line. So I'm just going to go ahead and do this just for completeness sake. And again, for those who are new to Lisp, just recognize that the issue is the tilde percent represents a new line there. So if you guys are looking at it, I encourage and wondering what this code looks like or wondering what it does, by all means, I encourage you to first go to Practical Common Lisp and go through that. I mean, watch the stream, but go through Practical Common Lisp and some of the other introductory Lisp books and our series on Practical Common Lisp, and come back to this video because it will make much more sense, especially when we start talking about projects and things like this. Now, in order for this project to actually be installable, we need to first go ahead and create a library. Okay, so what I did is I ended up using CL project, another Fukamachi project, and created this into a proper Lisp project. Okay, with an ASD file, as is shown here. And this ASD file, for just a reminder, is just a basic file that comes up with some metadata on the project, which I have not yet filled out. And it will provide some licensing. You provide some of your components that you may have in different subdirectories inside your List project. For those of you looking at this is just a simple system definition. I'm just going to fill this out with a simple program that computes factorial with Roswell deployable script. So for folks who are actually going to look at this, this is already going to be published on Atlanta FP's GitHub repository for you guys to download. Now, what I'm going to do is I'm going to go into the source directory and take our scripts callable function here. I'm just going to merely put this into this function and provide a little doc string here, computes the factorial of n. And we're just going to go ahead and save this guy. And this is going to be the start of our actual library that we're going to be creating. Obviously, this is a very simple one, but we're going to probably add to it more on, especially when we start getting into figuring out how to leverage our GitHub Actions. Now, this is all well and good. We now have this, but we need to be able to call this in our program, right? In our Roswell directory, right? So what we're going to have to do is we're going to have to first go and load from using quick load our project, all right? And then what we're going to do is we're going to actually make this guy here. Remember, this is not exported yet. We're going to export our factorial function. Let's go ahead and make sure that this is all working. Call up Sly, fire up Sly so that we have this available. 1 second here. My apologies. I don't like the fact that it did that. There we go. Go ahead and call quick load on EFP fact, which will see it. And let's go ahead and make sure our function, once we call AFP dash fact, and let's make sure that you can actually see fact. You can. You see that it's fact n, and you can go ahead and call it. It'll go ahead and compute 120. Now, what I'm going to do here is I'm going to also fire up an E shell because I'm running this in Emacs, and I'm going to go up a level and go into our Roswell directory and then do a simple ROS build of this fact. Oh, sorry. My apologies. I typed that wrong. Go up, ROS. Okay. And what this is doing is oops. Okay. So 1 second. I have to go and go into this. Sorry. Go into fact.ros. I'm going to have to call this now with AFP fact colon fact, because now this is an exported function in a package. We need to be able to actually go and call it this way. Just a reminder for folks, the colon is for exported symbols. Colon are for symbols that are not exported, but do not use colon when you're dealing with packages, just merely because of the fact that there's a reason why they were hidden from you. All right. That means tomorrow the library author may decide this symbol does not need to be exist. You'll unintern it, and now you broke your code. So only try to take advantage of exported symbols. And if there's a symbol that is not exported from the package, go and talk to your library author and make sure that you can convince them some way that it is necessary to go and export it. So with that, let's go ahead and restart and rebuild. You're going to start seeing that you are, what is it complaining about now? Let's go up here. AFP fact does not exist. 1 second here. This is a local project, so this should actually recognize the fact that I have loaded this from my local directory. Oh, never mind. I am using the wrong thing. What I need to do is include Quick Lisp here in this case, because we're not using Quick Lisp. There we go. So now we actually have a project that's leveraging Quick Lisp. So, but this is actually the way you're going to have to end up leveraging it. If you don't need Quick Lisp and you know that you're going to put everything isolated into your script, by all means use +Q. But again, for the sake of actually building executables that are going to be ROS installable, and I'm going to show you this in a minute. And if this is a bug for folks who actually are maintainers of Roswell, or folks who are actually looking at this are going to talk to the maintainers of Roswell, by all means, correct me if I'm wrong. They're going to that you're going to eventually fix this. If this looks like a bug, but right now, as it stands, you're going to have to actually set up this environment. This is kind of the approach that I had to take to actually get this all kind of working. So we have now our executable, and as you can see, if we run it, it's going to say usage. Obviously, we've tried this before. It's going to go ahead and compute our actual factorial, but we've separated the library code from the rest of the executable. So now we have a script that's calling out to our functions. It may take command line arguments. This might become a complete um, sophisticated tool that you might want to use separate, that you don't want to put in your code, because you're going to probably add command line options that may be necessary for your command line tool, but may not be necessary for if you're going to building, like, say, a UI that on top of this. So this is a good separation and good refactoring that we're doing here, but we have to actually get this now ready for deployment. So what we're going to first do is we're going to check this in. We're going to actually leverage Git here. Let's check our status to make sure everything's been modified. Let's go ahead and remove, so we don't accidentally um, uh, add that executable into our what's it our project. And let's going to go ahead and do this. And again, for folks who haven't seen the file directory structure, again, this is your standard CL project. Now, I'm sorry about the double markdown file. I created a markdown file using .md. The CL project generator also creates a markdown file, which I think is the one that is this one, right? Yeah. So we can actually get rid of this one too as well, because this is actually unnecessary. Well, hold on. Let me just see what this one is. Okay, so let's go ahead and just get rid of this too as well. So now we have this kind of cleaned up to being a proper CL project. Make sure I have all my statuses here so I can make sure. Okay. We're going to go ahead and commit this and write a quick comment. Updated refactored CLI tool. Please, try to be as precise in your commit logs. That's pretty good practice. I don't have to tell most of the experienced developers that are on the that are watching the stream, but sometimes it's always good to remind ourselves. Refactor CLI tool into tool functions into a library and deleted duplicate readme. I know I'm not following Git hygiene here in terms of having of a title and a description where the title is actually 50 characters and then you actually go and detail it. But this is, I sometimes end up adding this, so this is not a huge deal. You can always correct that later on if you really need to or really want to. Um, so we now are going to go ahead and push this into our Atlanta FP GitHub repository. So now this is all pushed into our GitHub repository, and we can run this next command. All right. So notice that I'm going to show this to you first. If we run ls in our Roswell local projects, um, you're going to see the following. Okay, these are all the projects that I'm currently trying and checking out. But if I run ros install on Atlanta FP AFP fact, it's going to first call out to GitHub, grab the project, and then it's going to actually build the project for you, recognize that there is a script there, and then move it into um, Roswell bin. But there's an additional thing it just did. It actually downloaded it into your local projects directory. Okay, Roswell actually, for each script that you are installing from GitHub, it will always take that project and install it in, it'll take the source code at least and install it in your local projects directory. We also actually can see this because we downloaded the other day the Run Prove project from Fukamachi-san. So if you actually go and look at Fukamachi-san, these are all the projects that we have. We have Prove, obviously. If we go and ls into Prove, you'll see that it's the full source code into Prove, but it also has the Roswell directory there where we actually got the Run Prove tool. You may end up wanting to actually use this to grab projects that you may want to contribute to. This is one way of certainly doing so once you fork the project. But uh, when you ultimately do actually get these tools, just be aware that if you're installing it from GitHub, this is how GitHub is going to actually, well, how the Roswell tool will install that particular source code. Now, if it's coming from QuickLisp, by the way, if it's already a distribution in QuickLisp, it does something different. Okay, Roswell actually goes and I think grabs the source code and sticks it into a different directory. So it's the same actual infrastructure for both, whether you're using GitHub or QuickLisp. But the difference is I think QuickLisp's releases are all tar-gz'd up onto AWS. They're on S3. So just keep that in mind. Now that we have this installed, and I can show you that it's installed because we can just simply go up 2 levels into our main Roswell directory, go into the bin directory, do an ls, and we'll see factory here. If you have Roswell bin in your path, which I'm pretty sure I do here, and well, we can try this. Yeah, it does not have it. Let me just go ahead and add it. Export path equals $path and $home / Roswell / bin. Now, this is kind of what you would see if I'm running this on actual terminal on since this is not Emacs shell doesn't support reading in of the bash profile, I'm going to have to do this temporarily. Now that this is working, you can actually go ahead and see that if I run this, what? shoot, are you telling me that it still doesn't recognize that? Okay, hold on. Let me try something here. Let me, nil is not found. Echo dollar path is there. Okay. We will we'll if you're running this in the shell, you will actually see that it's actually part. You can actually run this, but we're gonna go ahead and use the full path for the time being, just because I want to show you something else that's available. This um, when you first run our freshly minted executable, you may end up realizing that there's about a few second pause, maybe a couple of a second or two pause. All right. And when we run this, you could see it's actually initially runs at 1.102 seconds. All right. If we actually try to run it again, it'll be roughly around the same thing. This is slightly different than um, what you may end up seeing if 1 second here. We're getting the same stuff here. Okay. And okay. So let me try and see if I can actually share um, my terminal window, and then I'll switch back to this. Give me a second. Port, okay. Okay. So let me go back to this. Stop this for a second. Share my terminal window. Okay, good. Okay, so if we run this here, okay, you can see that fact is actually located here. If we do which fact, you can actually see that it's actually available in our local directory. If we try to do time fact, you'll see also that it's going to take a couple of seconds to actually load this. The reason for this is because it's actually taking time to load up the Lisp environment and runtime. And you can actually see this. If we go into our build here, sorry, if I go into the build directory here and we do ls.ls.fact, you'll see that fact is actually a fairly small executable here. All right. There's a couple of things that it is doing though, mainly to actually run the script. And that includes things like in our case, we're running which have you, we're running a quick Lisp to actually go and actually load our AFP project, and the it does a little bit of tree shaking things, as you can see here. Um, Usually, it's actually better than some of the other stuff that's out there. Um, but there's also other ways around it. Like this is actually probably the better one. If we try to build it ourselves, you'll see that you might get very differing results. You might think that you would want to actually run this as is. I wanted to show this to you just because this is something that I encountered the other day. And if you're thinking that it's going to it's you could speed up some of it. There's a couple of options that you have to actually speed up the executable, but I think if you're going down this route, I don't believe ROS install gives you like say disable compression, things like this where you could speed it up. It might be, but I don't think I didn't see that option in there. We could try it in just a second just to see if that piece works. But I'm going to go ahead and first show you what I'm talking about when you're running the ROS build tool. Recall when you take your executable here, I'm sorry, your script here, and you run it through ROS build, it's going to fire up whatever your default Lisp is, which in my case is SBCL. And it'll actually jump and generate this nice executable for you, which if you look at right now, it's going to be about 13 megs. Okay. And if you try to run this the first time, this is going to be probably about 1 second every time. All right. And this is not including computation or things like this. You can actually speed up the executable by simply preventing it from doing any sort of like advanced compression, because this is actually a compressed executable. It's less compressed than the one that the actual ROS install tool used, because there's some additional command line options that it uses that I'm not for the default Lisp that I'm using. But the what's it the by default, if you're using ROS build and you're just doing a save Lisp and die, it's going to be doing this where it runs a couple of compression utilities, some tree shaking, tries to get you as much of a um, optimized and small executable as possible. All right. Now, but that comes at a cost of loading up the application. It might take a second or two. Now, this is still faster, by the way, for folks who are saying that this is pretty slow compared to, say, Python and stuff. I was like, this is actually significantly faster. Just the default stuff is significantly faster than Java or even C Sharp in terms of startup, especially in client mode. Those of you who are going to talk to me about Java server mode, I'm just going to say for the record, I still have no idea how you would do Java server mode, warm it up, and start it up inside of a container, so that it actually uh, misses out on those 4.5 or 6 seconds to actually start up the actual Java virtual machine before it actually runs a application. Those of you who know ways of doing that, put your comments in the YouTube comments. I would love to hear those optimizations. Um, but for the time being, I'm just going to assume that there is not a way. um, so there is a way to speed this up, or at least give you even a speed up the startup time for this. And the way we do that is actually a couple of things. Um, One is what we talked about or last time, which is stop loading Lisp. But we're going to talk mainly today about making executables, but making executables not just by the default way, which I just showed you earlier using ROS build, but also passing in ROS build dot disable. And by the way, folks who are looking at the documentation, you might be thinking that this is the right way to actually call out to ROS build and then call this into to your script, right? But as you can see here, as soon as you do that, it's actually the options are flipped. So you actually have to call ROS build on the script with the command line options that are necessary. All right. When it does that, it's just going to go ahead and expand uh, the executable slightly. All right. It goes from 13 megs to like 42 megs. But if you look at the startup time, it goes from 1.08 seconds to zero point 0.006 seconds. So that's a significant drop in startup. Okay. Obviously, I'm probably overstating the obvious since the numbers speak for themselves. But if you want a really fast executable in Common Lisp, it is clearly not an issue. You can actually get it as fast as you want it to be. All right, and even if you run this guy, it's actually really, really fast up until you run, significantly large numbers. Now, even with complicated applications, this is going to be the case. Um, you will it's essentially creating a fat binary or with all the necessary dependencies available, and which makes now everything a simple jump or branch. It doesn't have to do any additional loading from the runtime to actually get your application to run. Okay, which is the what the other approach does, and that which is why it takes some significant uh, overhead to actually start up the application, but it does reduce the amount of uh, the size of the actual binary if that's what you need it to do. Questions? Okay. The next thing that I was going to talk about is since we were on the subject of building executables, and Roswell installable scripts. On the Roswell website, there actually are a series of Roswell installable scripts that you can use. In fact, it's one of the things that I like about Roswell. The community there actually has a bunch of awesome scripts already available for some fairly useful things. One I've already showed you, which is the web server ClackUp. The other one, which is actually a tool for Clack. The other one is the run proof tool that we've installed yesterday. But a third one that's also equally useful that I just found out the other day when I was debugging my issue is ROS install. I think it's CL project, because I already have CL project. Most folks know that I use CL project on this stream. On the day-to-day thing, but I didn't realize that CL project, if you install it using ROS install, not using quick load, it actually installs a script called make project and easy project. Okay, sorry, make project is this one, easy project is a different project that actually does the same sort of generation. The nice thing about this is now if I want to actually go and create projects, I don't necessarily need to fire up a Lisp interpreter anymore. I can actually Lisp REPL. I can just simply start running make project, and make project gives me the ability to actually go and specify the path, specify the name, description, all the dependencies, and it will generate the project for me. So just to give you kind of an idea, if we run, make project on, say, and all of these for folks who are looking at this, all of these command line options should be familiar to you by now, because I use these same arguments when I pass in stuff into CL colon make project, which is the API call internally when you call it from within Lisp. So now I could just simply do this, do local projects, and say test project, specify some stuff related to the name is test project. Ignore the description, license, and all that. You can actually then do depends on and say Alexandria or something like that, or even split sequence, and it will generate the project for you. Boom. So now if you go and look at it, you now have your tools for you. Another interesting utility that I found, because I use 5am, is there is a project called CI Utils. I did not realize that this was here, that are a series of scripts for just running utilities for continuous integration platforms. And since we're going to be talking in a bit about writing up stuff for GitHub Actions, this might be a useful tool to install. So let's go ahead and install that guy too. And again, I'm getting this from QuickLisp. I'm not getting this from GitHub. If I install this from GitHub using the GitHub URL, that would install it into local projects. In this case, is going to install it into the base project, which I'm forgetting now. I think it's like in was it in Lisp? I think it was quick Lisp. Quick Lisp. It's there. No, this was in where is it again? It was in no. This is where SBCL is installed. It should be in Lisp. Um, oh, that's right. This, I think, is where it is. Yeah, this quick Lisp is where it is. So if we go into here and go into installed, you'll see I think in releases, all of the stuff that's been installed on this project, including 5am and all this kind of stuff, including CI utils, I think is somewhere in there. Yeah, CI utils is the text file. This is all the metadata, by the way, when stuff is available on QuickLisp. And then if you want to see the systems themselves, you go into here and you can actually, sorry, not here. You need to go into the quick Lisp directory. I think it is in desktop CI util star. This is in software. That's what I was looking for. Dist quick Lisp software. There we go. So here is where you would see these scripts. And again, as with anything that's running with Roswell, you will see this Roswell directory that has all of the scripts. So in this case, we have a register project thing and of course run 5 a.m. And run 5 a.m. is something that you would probably want to use as part of the CI system where you end up calling up uh, 5 a.m. to actually run your tools. And as you notice with this particular tool, it also will set up stuff related to coveralls for code coverage if you want to use that too for your CI integration strategy. All right. And let's go to here. Let's go back to, let me just see if I can just do this for NW for the time being. Do Emacs NW, see if we can do this. All right. So this is all well and good. We now have kind of our setup. We now have our ability to install scripts from GitHub. I've shown you how to leverage the scripting environment. There is some stuff. Did I miss anything related to? Um, yes. So one thing to note is you may have noticed that there is a uh, a build function that is automatically called when you run Roswell install system. And if you don't want that to actually run or you want to override it, you can actually set up a uh, a hook to Roswell called a build hook. And when quick load is complete, the one thing that I will point out is that's if you are running. If I understood the documentation correctly, that is if you are running Roswell from within a Lisp REPL. I'm not quite sure how this would work out in setting up the build hook when you are trying to do ROS install from the outside. So beware if you're actually looking into that. Um, so you can use these executables and scripting environments things that I was talking about to essentially write your own utilities and then run them like in various forms on your system. But as we saw last week, Roswell can also, and this is probably one of the bigger ways I've been using Roswell. Um, you can install a bunch of different implementations on it. Okay. Um, the one thing that I think is important to note, and and I should have actually called this out here, is anytime you install anything with Roswell, if you do Roswell list installed, it's going to give you only the implementations that you've installed. It will not give you an implementation of the tools that you've installed with Roswell, right? That's just something that you need to just be aware of. Um, there isn't anything like the ROS list ASDIF stuff is all related to like what versions that ASDIF is available from GitHub, and it can grab the latest for ASDIF. I think right now when when we updated it Roswell last week, I got the latest ASDIF, but you know you can always check and see if you can install the latest one. Um, uh, the the Git tool for Roswell is all the packages that you've installed with Roswell. But it does not include Yeah, it does not include the GitHub URL that's provided in there. So earlier when I said list installed is not everything that's installed in your system. Those are just implementations. Like I said, list git is where you would end up finding your tools. And then of course, Roswell list versions are all the supported versions that you can actually go and install from Roswell. We've actually seen that. And I think the final one that I haven't covered is actually there's two more. ENV. ENV is nothing more than what was it? It was just the environment variable. What was it? It was again the environment variable for ah, it was the environment variable for it's the environment for the current Roswell, like any environment variables that you need to have defined, I think is what list env is for, but I'm not entirely sure. Don't quote me on that. Dumps is for dumped binaries. So if you do list dump, um, it's actually going to look for if you decided at some point that you wanted a particular developed environment to be available and you don't want to set it up every time that you start up. So this is usually the case where you are dealing with you know, setting up a development environment for individuals to actually go in and be able to just hit the ground running. And then another case is obviously testing environments that you can actually set up to through Quick Lisp 2 and set up all the dependencies for it. You can use Roswell's forgetting I think there's a dump command for it to actually go and build it. Uh, And what this will do is once you do a save Lisp and die, for example, it can actually then keep track of the image for later use. Let me see if there's a way. I think that was from um, forgetting now how to actually do this again. I think it was in Rod's build help. Rod's help build. We'll create a dump executable. Um, there we go. So you're gonna have to you can use ROS dump to actually go and do this, even though this is not documented. It is available for your needs. If you want to actually leverage, especially creating different environments for your own needs. Um, okay, so now it's going to be our main topic, which is going to be using Roswell for testing. So Roswell allows you to hook up into any existing continuous integration system. A couple of the more popular ones that are being used with Roswell, and this is before the advent of GitHub Actions, was Travis CI and Circle CI. I'm not going to cover Travis or Circle today, just because although I am familiar with Travis and Circle, there's enough documentation on how to set up a Travis CI environment, Circle CI environment for Lisp that I don't think and more importantly, I think a lot of folks are now moving towards using GitHub Actions. That I'm going to err on the side of caution and assume that the audience and you all are interested in dealing with GitHub Actions. So if I'm mistaken, go ahead and put a post in the comments so that I can actually go and I'll set up a separate talk about uh, setting up Travis CI and Circle CI for your continuous integration. But it'd be useful to at least set up uh, setting up with a some sort of CI strategy so that you can actually leverage all these project all these nice tools that are available in Roswell, and you can test your code and have high quality code out. Looks like there's a question. Oh, There's a question in GitHub. Okay. Thank you for telling me that you were. There's a question about a comment about interest in GitHub Actions. Yes, I know a lot more folks are interested in GitHub Actions. So let's talk through this particular example. Every project that needs to go into to use GitHub Actions, most of you know, GitHub Actions is provided by GitHub. It's automations that allows you to test on Mac, Windows, and Ubuntu. Um, in order to run this, there's going to be a basic project that you need to provide, and it needs to be part of the project, if I remember correctly. It needs the CI system needs to be part of the project. I said that, yes. I think that's where it's supposed to be. Um, Let me just double check this here. I'm running this in GitHub Actions. I'm always forgetting how to start this again because once you set it up, you just you just run with it, right? So let's go and talk about uh no. Let's see here. Um okay, let's try this example from I made a note of this to try what was said in uh the GitHub action the documentation on Roswell, and let's see what happens here. Okay, let's see if this all works and go from there. All right. So the first thing we need to do is go back to what we had earlier because we're gonna first set this up and then we're gonna run our test, write a dumb test, and then go from there. And one moment. So in our AFP fact directory, not this one. I have to go into Atlanta FP dev inner tool. So in our AFP fact directory, we're going to create a hidden directory in here called .github. All right. And in there, we create our workflows directory and then create what's called a ci.yaml file. This is going to hold, oops, and I made that into a directory, not into, this is not what I wanted to do. Now I could do this. GitHub workflows ci.yaml. This ci.yaml file is going to hold the different stages that we want GitHub Actions to run. Okay. So the name of the project that we're going to call this is obviously AFP Fact, which is what our project name is. And we want to specify when we want these to run. In this case, we want this to run on push. And we want to specify what jobs that we're going to actually run on this, okay? There are different jobs that you can actually run and specify how these jobs need to run. I encourage you to, for folks who are unfamiliar with GitHub Actions and workflows, to go and look at the uh, the GitHub Action documentation for more information on this. I'm just going to quickly breeze through this based on what I've seen in the documentation, in the Roswell documentation, just because this is a fairly straightforward thing that it's attempting to do. And a lot of the metadata it's getting straight from the matrix that you're providing, and we'll work through it and see if there are any questions. All right. Um, but if you need more information, want to know how GitHub Actions actually works, this is not a tutorial on GitHub Actions, just how to set it up for folks who want to use GitHub Actions with Common Lisp through Roswell. All right. So we're going to create. Are there questions? Okay. Let's hear somebody that had a question. Uh, okay. Let's have. All right. So let's go back to this. So, like I said, jobs will hold all the stages that you're going to try to do. Our main job here is just going to create a test job. Okay. We're naming the test job to being based on the matrix of different Lisps that we may want to test on and what OS we want to actually test on as well. Okay. This is very useful, especially for those who are trying to write cross Lisp, cross platform projects that can run on multiple platforms. So this specific thing runs on with the Matrix OS is essentially notifying GitHub to, provision a particular operating system and run on that provisioned operating system a particular version of the Lisp that we're trying to test on. Right. So the strategy is going to ultimately determine our our actual matrix here. Okay, so we're going to provide our test matrix here. We're going to provide which list we're running. In this case, we're going to do sbcl bin. I can also add ccl bin here because I'm not adding anything necessarily into this, but let's try this out, see what it comes up with, and we'll work our way up. Okay. And then obviously we're going to specify the versions of uh, Linux that we're running. In this case, we'll just run Ubuntu and then Mac OS latest too as well. So this way, again, we get this provisioned accordingly. Once we do that, we want to provide the steps that need to be done to actually go and run our tests. All right. So here, this should become pretty straightforward. This is for folks who are looking at Travis CI or Circle CI or other CI systems. Even Jenkins, I think, adopted this YAML kind of style format. You could say uses. And here, the only difference is you're actually specifying what GitHub action you're trying to leverage. There are a bunch of predefined GitHub actions in the documentation. Here, we're specifically trying to use just couple of the default ones that are there, and you could specify the action to run. Grab, like for example, here we're going to run using actions slash checkout that's already available for us. And then we're going to actually go ahead and specify the step that we're going to be doing. So the first thing is obviously installing Roswell locally on the box. You're going to specify the environment that you're going to be using. And here, environment variable obviously is going to tell uh, Roswell, which Lisp it wants you want it to install, and this is going to be based on what's in our matrix. So if you have, in one case, just CCL bin, it'll go and install closure CL. If you're running the what's it the SBCL bin, it's going to try and grab the latest version of SBCL, hopefully, because I think by default it tries to install what we saw last time, which is 2.04, and that has some issues with the current version of Roswell. Next thing is we're going to actually provide the step here in this case, which is uh, grabbing the actual command to actually go and install Roswell. This again, for simplicity's sake, it went with just using because most operating systems, in this case, both Mac and Linux, will provide this. It is using the curl operating command that's already available on the Roswell documentation. Now we have the first step of installing Roswell. We're going to go now do the next step, which is actually installing Rove, which is the uh, what we were using before to actually to run our commands. Okay. So here, this is the unit testing framework that I think is the successor to Prove that Fukamachi-san wrote. This to install it, we're going to have Roswell install, and then after we do it, we can just go ahead and install Rove using Ros install Rove, and then we can actually run our tests. And running our tests is actually pretty straightforward. Um, we can actually provide here um, the command first, provide the appropriate path variable here because we need to have this in the path to actually go in and run our code. Otherwise, we won't get access to Rove. And then we need to just run Rove in our AFP fact.asd. And it'll go and find the appropriate test framework and then, build it up. All right. So this is all here. This actually should work. Let's go ahead and add our GitHub commit, our GitHub Actions, committing GitHub action config. And for folks who aren't creating public repositories and private repositories, GitHub Actions has a pricing model. I'm using since I have an account with GitHub, I'm just showing this for illustration purposes. But if you're going to use this for your work, I encourage you to first look up their pricing so you don't accidentally get burned for their pricing, right? Just a fair reminder about this. So we commit this, and then let's go ahead and push uh, this into our master, and we should be good. All right. So now I would have to, I think, have to show you guys um, how to invoke GitHub Actions, and then we can actually go and look into that. Give me a second here. I'm forgetting now. Where is? Okay. So let me just make sure I do this. Um, So for me to show this, I have to go into Actions. Oh, awesome. Okay. So let me share my screen, my browser screen. I'm going to switch over to my browser screen. Apologies for folks who are just tuning in. I am like flipping and flopping between different things right now. Did not want to. Okay. And let's just show this to you. So to view GitHub Actions, and I'm just going to start this, just to review for folks who have not seen GitHub Actions. This is the main Atlanta AFP fact project. And if you go into the fourth tab here, you have our actions, and these are all the workflows that are going to be run on this. And it actually just simply ran our script, which goes through all the jobs. It actually ran SBCL on Ubuntu and SBCL on Mac. And you can even see it actually go in and show the Git versions that it got. Particularly in this case, it's grabbing the actions from GitHub to actually install into the box. And then it installs Roswell here, as you can see here. Installs Rove. Okay. it attempts to run our tests, but since we have no tests here, it'll say that there's zero tests. It's actually the simple dumb test that's completed. So then it actually then runs the complete job. All right. Pretty simple, pretty straightforward. As you can see, for folks who are looking at the YAML file, it is who are not familiar with GitHub Actions, there are some pre-built things that we use, like checkout here, but there's also ways to express your own custom actions, and you just need to specify in the YAML file what your steps are to actually go and build them. Um, Again, this is not a tutorial on GitHub Actions, but for folks who are using this for Common Lisp especially, this will allow you to try this in different streams and so forth. I mean, sorry, in different distributions of yeah, and different Lisps, Lisp implementations by just simply expanding on this Sorry about that small hiccup. So to show you that this can work with different Lisps, I'm not going to expand the test suite just yet. I'm just going to simply add an additional command in here. Um, you're going to see this. I'm not going to switch back. Behind the scenes, I'm going to go ahead and update the change here and update this our workflow model to also test on, say, CCL bin. All right. And let's go ahead and commit the L bin. All right. And let's go ahead and commit this to added CCL bin to test matrix. Okay. And let's go ahead and push this. I'm going to briefly switch back to our actions window here. Okay. You're going to see this in a minute. When I do a push, project, it's like Travis CI, this thing is going to recognize that you need to change it. And then here, if we go into our projects, it's going to show all the jobs that it's creating. It's provisioned now all of the different OSs for us, and it'll actually now run our CI steps. Um, it's it's just that simple now, much like before. Now it's everything centralized in GitHub. Of course, if you are doing this on a professional project, there's going to be a cost to it. If you're doing this on an open source project, I don't believe there's a cost, but it's up to a certain number before they will start. They may start charging. I don't remember the details there off the top of my head. Go to GitHub Actions' pricing model to go and get more information on that. But this should convince you more than ever that honestly, there's no excuse, right? You now have an ability to test your software in a CI way, whether you're using Travis CI, Circle CI, or GitHub Actions. I'm sure there's a way also to test it if you really wanted to on using Jenkins if you're doing it locally. Obviously, doing that would probably end up using things like CI utils and things like this, but it's not going to actually matter, whatever your CI strategy may be. The point is that Roswell has the tools to actually go in and do what you needed to do to run your test. You just need to add the appropriate steps in your CI configuration file to actually do continuous integration with Common Lisp. Finally, I wanted to just touch briefly on something I read about just distributing the software in the documentation, just because it's a very useful thing to know. Um, you could you may be wondering how you should actually distribute your applications. My personal opinion is the best way to distribute your applications right now, at least if you're using Roswell as your default strategy, is to do what I was showing you earlier, which is set up your project, abstract out all your necessary functionality, create separate sets of libraries for each of your individual tools that you may want to be part of that project. Go ahead and create a Roswell subdirectory. Add those scripts, those Roswell scripts that we saw before by doing Roswell init with the with the script name, and then go ahead and submit all that into GitHub. And then eventually, when you're packaging your stuff, submit it into Quick Lisp, and Roswell will take care of the rest if you just tell people to install your command line tool, especially in the case of command line tools, to do ROS install on your command line tool, and they can either grab it from GitHub or from Quick Lisp, and it'll do the rest for you. And it's just that simple. Are there questions? Great. So that's the all I have for today, honestly, just because this is some particularly useful information. Now, there is a lot to digest here, although I know I did not create more example tests here, but folks who have seen me talk about prove in the past, more or less, you could go back to earlier episodes where I've done actual examples of adding unit tests to prove and rove and actually running these things. You can use those earlier episodes to actually go back and implement this example using Roswell and get your projects running on GitHub Actions. Until next time, I do appreciate you all joining us. A couple of reminders: Atlanta Functional Programming is looking for speakers. So if there's something that you want to talk about, whether it's Lisp related, Haskell related, or what have you, by all means, drop me a line. I'm available on Slack, usually on the Tech 404 channel for folks who are in the Atlanta area. For folks who are outside of the Atlanta area, you can reach me on functionalprogramming.slack.com. That's the workspace for the functional programming community. And I'm also available on the Discord server, on the Lisp Discord server, has Bugram. All my alias is Bugram on all three of those. By all means, you can get a hold of me there. Additionally, for folks who are interested in Haskell, tomorrow we're going to be continuing our discussion on and finishing up actually our discussion on functors with Haskell and with the Haskell study group. It's at 7:30 to 9:30 Eastern Standard Time. Please check your time zone for the appropriate times for your particular time zone. And until next time, I do appreciate you guys joining us. Have a great evening.